So what is Kafka? Apache Kafka is an open source distributed event streaming platform, also a message queue or message broker system. In traditional HTTP networks, a client sends a message to a server. If the server is slow, we get latency. If the server dies, the request fails and has to be retried. The client is coupled with the server. However, in Kafka, the client sends the message to a Kafka broker. The server who may be interested in the message will get the message from the Kafka broker. This decoupling creates a lot of architectural advantages. It adds scalability and high availability because we can scale clients to produce more messages, add more brokers to deal with messages, and scale receivers to process messages. Messages can also be replicated across brokers, further bolstering its resilience. In Kafka, the clients here are called producers. Messages go to brokers, which are Kafka instances. Servers that consume messages are called consumers. Messages are stored on the broker in what's called a topic. Topics can be divided into partitions, and the message goes into a partition. This allows scalability as we can tell Kafka to store copies of that message on separate brokers in different partitions. When message 2 comes in, it's replicated and distributed across multiple brokers in partitions. Same for message 3. If a broker dies, messages are not lost. The consumer who is interested in messages 1, 2, and 3 can subscribe to the topic. It'll start receiving messages 1, 2, and 3 in order with an index number where it read up to. If the consumer fails or crashes, it can use the index number to retry and continue where it left off. Welcome to another video, and in this episode we'll be taking a look at Apache Kafka. We'll take a look at a Kafka instance by building up a Docker file. We'll then take a look at a Kafka topic and how Kafka stores topics on brokers. Then we'll proceed to take a look at a producer on how to produce messages into a Kafka topic. And finally, we'll create a consumer that will read messages from this topic and process them. We have a lot to cover in this episode, so without further ado, let's go. All things start with a Docker file. We're going to install a Kafka broker and run it as a Docker container. This will allow us to create 3 Kafka brokers as separate containers. Then we'll ask Kafka to create a topic called orders and split it by 3 partitions, 1 partition on each broker, and this is where order messages will come in. So if we take a look at my GitHub repo, I have a messaging folder, and in the messaging folder I have a Kafka folder with a README. And this is our introduction to Kafka, pointing to the official docs, how to build a Docker file, and all the steps I'm going to be showing you guys today. So be sure to check out the link down below to the source code so you can follow along. So if we take a look at my README, the first thing we're going to be doing is building a Docker file. So what I'm going to do is head over to the Kafka website, and on the right here is a link to download Kafka. And here they have links to the latest version, the documentation, release notes, as well as the zip file for the installation. So if we head back to my repo, we can see in the messaging Kafka folder, I have a Docker file. Now Kafka needs the Java runtime in order to run. So what we're going to do is create a Docker file starting with the Java runtime and then installing Kafka using a simple Docker file. So this Docker file is very straightforward. The first thing I'm going to do is say from OpenJDK, and I'm going to run the Java runtime on Buster, which is a Debian container. Then I'm going to say apt-get update and install curl, and I'm going to use curl to download the latest version of Kafka. And then what I'm going to do is I'm going to provide environment variables to set the Kafka and Scala version. This is used to construct the URL. So if we take a look at my next statement, I'm going to create a temporary folder where I'm going to download all the Kafka binaries, and then I'm going to proceed to download it with the URL provided in the documentation of Kafka. I'm going to say curl, and I'm going to call the archive.apache.org, and you can see I'm going to download a specific version of Kafka here and get the TGZ file. Then I proceed to download that into a temp directory, and I'm going to go and extract it using tar. Then I have a simple file on the outside here called start Kafka, which is a shell script that will start up the Kafka instance and point it to a configuration file. I'm going to copy that into user a bin. I'm going to give it execution rights, and I'm going to create a command to run that file, which will start up a Kafka instance. Now, the cool thing here is that this Kafka installation that we're downloading has a lot of files to allow you to start and stop Kafka, as well as produce messages and consume them. So it has a bunch of shell scripts that we can use to explore Kafka, which is really useful. So what we're going to do is build up this container and then take a look at those. So to build a container, what we're going to do is change directory to the messaging Kafka folder, and then we're going to say docker build -t and then tag our image as Kafka 2.7.0. So I'm going to copy this, paste it to the terminal, and this will go ahead and build our container image. Now, as I mentioned, the Kafka installation comes with a bunch of cool scripts. It comes with a script that starts a Kafka instance, stops an instance, as well as some cool utility scripts that allows us to create a topic, describe a topic, a producer that creates a message and places it into a topic, as well as a consumer that reads messages from a topic. Now, to take a look at these cool utilities, we're going to explore the Kafka installation. And to explore it, we can run our container by saying docker run --rm, call it Kafka, and run it in interactive mode, and then also create a bash entry point. So I'm going to copy paste this to the terminal, and this will start up our Kafka instance and provide us with a terminal where we can run commands. So what I'm going to do to explore the instance is I can say ls-l and point to the folder where Kafka was installed. And you can see there's a bunch of cool scripts in here. There's a Kafka console applications to consume and produce messages, as well as a Kafka service start and stop script. There's also a script that allows us to deal with Kafka topics. There's also an important script, which is the Zookeeper service start and stop, and we'll come to Zookeeper in a second. Now, since we've installed Kafka to the /Kafka folder, another important folder is the config folder. If we take a look at that by saying ls kafka /config, we can see a bunch of base configs that Kafka provides us. So there's a server.properties, which is used for Kafka, which is a basic configuration file. And then we also have a zookeeper.properties, which is a config for Zookeeper. So the Kafka installation comes with a basic configuration file for both Kafka as well as Zookeeper. And we can explore that config file by saying cat /kafka /config /server.property, and this is the base configuration file for Kafka. Now, to take a look at these configs, I think the best practice is to create another terminal. So I'm going to run another terminal. I'm going to change directory to the messaging Kafka folder, and I'm going to use the docker copy command to copy a copy of that Zookeeper and that Kafka configuration file to my local machine, so we can make changes and then mount that config in when we start up Kafka instances. So to grab these files, what I'm going to do is say docker cp, and I'm going to copy it out of the Kafka container, out of the config folder, and I'm going to copy it to my local machine. And then I'm going to say docker cp, and I'm going to copy the Zookeeper configuration file out as well. So I'm going to paste that, and now I have both configuration files on the left, one for Kafka and one for Zookeeper. Now, because I want to run 3 instances of Kafka, what I'm going to do is in my messaging Kafka folder, I'm going to create a new folder called config. And in that folder, I'm going to create 3 folders, one called Kafka 1, another one called Kafka 2, and a third one called Kafka 3. And then what I'm going to do is move the server.properties file into my Kafka 1 folder. And then I'm also going to create a Zookeeper folder inside the config folder. So now we have 4 config folders, one for Kafka 1, 2, and 3, as well as Zookeeper 1. And I'm going to move the Zookeeper config into the Zookeeper 1 folder. So now we've split out our configs for each of our instances. So let's take a look at the Kafka configuration file. So in the messaging Kafka config folder, I have Kafka 1, and I have server.properties inside there. Let's take a look at that file. And the file is well documented. We can see we have broker ID, and this is the unique ID of each broker. So what I'm going to do is I'm going to set this ID to 1 to match Kafka 1. And then we take a look. There's a section here for socket service settings. We can specify how many number of network threads we want, number of IO threads, and this may include disk IO, as well as some buffer settings we can set here for message buffers. And next up we have have log basic. So this is the log directory where Kafka will store all the messages. So it's important to note when we run this as a Docker container, we may want to mount this folder into the container so that it is persisted among reboots. If you're running in Kubernetes, you might be using a persistence volume to mount this folder into the container. So if the Kafka container restarts or crashes and comes back, it will still have all its files persisted. Then we can also specify the number of partitions by default. There's also a setting regarding retention hours. This is the minimum age of a log file eligible for deletion due to age. So this is basically the default setting for how long we want to keep messages on disk. And then we also have Zookeeper settings to where to connect to Zookeeper. So currently that's set to localhost 2181. We're going to want to go ahead and change that. Since we're going to run Zookeeper in a different container, we're going to change it to its host name, which is going to be Zookeeper-1 on port 2181. And we can also set a timeout for connecting to Zookeeper as well. Now for the Zookeeper config, if we take a look at that one, it's very simple. There's just a data directory on where to store data, a client port, a number of max client connections, and an admin server and admin port setting, which I'm just going to leave as the default. So next up, we're going to want to create a config for each of our instances. So I'm going to take the server properties file, I'm going to copy, paste it into the Kafka 2 folder, as well as the Kafka 3 folder. And then I'm going to go to the Kafka 2 config file and change the broker ID to 2. And I'm going to go to the Kafka 3 file and I'm going to change the broker ID to 3 because the broker ID has to be unique across each of the brokers. And that's it for the Kafka configuration. Now, in order to run Kafka, you saw in the configuration file that we need to point to a Zookeeper instance. So what is Zookeeper and why do we need it? Zookeeper is a centralized service for maintaining configuration information, naming, and providing distributed synchronization for Apache services like Kafka. Zookeeper keeps track of the status of Kafka clustered nodes, and it also keeps track of Kafka topics and partitions. Now, Zookeeper helps make Kafka highly available, especially when running multiple Kafka instances as a cluster. In this demo, we'll be taking a look at running one Zookeeper instance for demo purposes. If you'd like me to cover Zookeeper in more detail in a future video, leave a comment down below. Now, we saw earlier that the Kafka installation comes with a Zookeeper script and a configuration file. So let's go ahead and take that and build a separate Docker file for Zookeeper. So what I'm going to do is in my Kafka folder, I'm going to create a new folder called Zookeeper, and in here I'm going to create a new Docker file, and the Docker file is going to look almost identical as the Kafka one. I'm going to start up by running the JRE buster for Java. I'm going to go ahead and provide the same environment variables. I'm going to go ahead and install curl, download the same version of Kafka, extract it, but this time I'm going to point to the start Zookeeper script and start that one as a command. If we take a look at the Zookeeper folder, I have a copy of that, which is basically just running the Zookeeper service start script we saw earlier and pointing to a Zookeeper configuration file. Now, to build the Zookeeper container image, it's very simple. All I'm going to do is change directory to the Zookeeper folder inside the Kafka folder, change directory to that, and I'm going to say docker build -t, and I'm going to tag the Zookeeper image. I'm going to copy paste that to the terminal, and that's going to go ahead and produce a Zookeeper container image that we can run for demo purposes. So now that we have our Kafka container, our Zookeeper container, and we have configuration files for each of the instances, let's go ahead and create a Kafka network, run a Zookeeper instance, and then run 3 Kafka brokers and connect them. So to do that, firstly, I'm going to change directory and go one folder up to make sure I'm in the messaging Kafka folder, and then I'm going to proceed to create a Kafka network because I want to run all of this containers on the same network. So I'm going to say docker network create Kafka. That'll go ahead and create a Kafka network, and then I can start up my Zookeeper container first. So I say docker run in the background by saying -d --rm --name. I'm going to call it Zookeeper1. I'm going to run it on the Kafka network by using the --net flag. And here's the special magic. I'm going to mount in my working directory /config/zookeeper1, and I'm going to mount the Zookeeper properties file. This is the Zookeeper config file that we created earlier, and I'm going to mount it into the location where Zookeeper expects the config. And in here, I'm going to run the container image tag that I've just built. So I'm going to copy paste this command, and I'm going to paste it to the terminal and run it. That'll go ahead and start up a Zookeeper instance. I can then say Docker PS, and we can see we have that Zookeeper container up and running. Now you can see I have 3 separate Docker run commands for running each of the Kafka instances. To run Kafka 1, I'm going to say Docker run -d for background mode --rm. The name is going to be Kafka 1. It's going to run on the Kafka network, and I'm going to mount in Kafka 1 server.property. So this is the Kafka 1 configuration that we created earlier. I'm going to mount it to the expected location, and I'm going to run my Kafka image that I've tagged earlier. So I'm going to go ahead and paste that to the terminal, and that'll proceed to run Kafka 1. I can then do Docker PS to see that it's up and running. I can then proceed to run Kafka 2 in exactly the same manner. The only difference is the name as well as the location of the config. So I'm going to copy paste that to the terminal. That's going to run Kafka 2. I can do Docker PS to see that second instance is up. And then I'm going to proceed to paste the third command, which is Kafka 3. And if I do Docker PS, we can see we now have all 3 Kafka instances up and running. We also want to make sure there's no errors. I'm going to say Docker logs, and I'm just going to look at the Zookeeper logs to make sure there's no errors. And we can see there's just a bunch of info messages, so no real critical errors or problems. And then I'm going to do the same thing for Kafka 1, and we can see a bunch of info messages, all good. Kafka 2, as well as Kafka 3. So we're all good, ready to go. So now we have 3 Kafka instances linked to a Zookeeper instance. So next up, let's go inside of the Zookeeper instance and let's play around with Kafka topics. We can also use the producer script to send messages to that topic and see how Kafka stores it. And then finally, we can proceed to look at the consumer and how it consumes these topics. This will allow you to play around with the topic configuration as well as replication, and creates a nice sandbox on your local machine for test driving the Kafka features. So next up, let's create a topic that allows us to store orders for an online ordering system. So under my README, I have a topic section which explains exactly what we're going to do next. So I'm going to access the Zookeeper instance, and you can use any instance to do this, but I'm going to say docker exec -it Zookeeper 1 and create a bash terminal entry point. So I'm going to access that container, and then I can create a topic by using the Kafka topics script that is embedded within the installation. So I'm just going to call Kafka-topics and then call the create flag, and then also point it to the Zookeeper instance where to create the topic. And then I can also pass in a replication factor, and for this demo I'm just going to use 1 because I don't want to replicate it more than 1 for demo purposes, so that we can see how this message is stored. Then I'm also going to proceed to say I want 3 partitions, and this will allow us to distribute the message across multiple partitions. And then finally the topic name, which is called orders. I'm going to copy paste this to the terminal, and that'll go ahead and create my topic called orders. Then there's another cool feature of the Kafka topic script, which is a describe flag, which allows to describe the orders. So I go ahead and run that, and we can see this explains exactly how our topic is created and stored. We can see that we have 3 partitions. Partition 0 is on replica 3, partition 1 is on replica 1, and partition 2 is on replica 2. And this is because we've specified we want 3 partitions for topic orders. So to keep track of this during my demo, I'm just going to copy this output and I'm going to paste it to a text pad up here. So let's say we have a microservice architecture for our ordering system, and we have one microservice that produces orders. So what I'm going to do to simulate that, we're going to split up our terminal and create a producer. So to do that, we're going to use the producer script that Kafka provides us. So I'm going to say docker exec -it, and I'm going to create another terminal that execs into the Zookeeper instance. And firstly, I'm just going to register the consumer that's basically interested in orders. So this could be a processing system that looks at all the orders that's being created and processes them. So for this, I'm going to look at the Kafka console consumer, which basically bootstraps a server and looks at the 3 Kafka instances that we have running. I'm going to point it to the 3 instances, and I'm going to say that I'm interested in the orders topic, and I'm interested in all messages from the beginning. I'm going to go ahead and copy paste this and run this in our Zookeeper instance. So you can see this is now currently paused. So the consumer now sits and waits for messages to enter the topic. So to start producing messages, I'm going to split the terminal again. And this time I'm also going to exec by saying docker exec. I'm going to go into the Zookeeper instance, and I'm going to produce order messages by calling the Kafka console producer and passing in the broker list. So I pass in the 3 Kafka brokers, and I also pass in the topic where I want to create an order. And this script looks at standard in. So what I'm going to do is I'm going to say echo order with an ID of 1. So I'm just going to pass a message. This is just a random string I've created. This could be a structured message like a JSON file or XML file that describes the content of your message. In this demo, I just have a simple string called new order 1, and I'm going to pass that to the producer. So I'm going to copy the script and I'm going to paste it into my producer terminal over here. And if we look at the left here, we can see that the consumer has picked up that order already. So now that we have 3 brokers running and we have 3 partitions, we also have a message that's been produced by our producer and consumed by our consumer. It's important to explore these Kafka instances to see how the message is being stored. Now let's start by going into each of the instances to see where the message is stored and how it's structured. So once we have a message in Kafka, we can explore it inside each partition. So let's say docker exec -it Kafka 1 and go into Kafka 1. I'm just going to go out of the Zookeeper instance and go into Kafka 1. And then I'm going to say apt install -y, and I'm going to install a utility called tree, which allows me to visualize the folder structure. And then we're going to take a look at the folder where we've told Kafka to store logs. And this is under temp Kafka logs. So I'm going to run the tree command on that. And if we take a look, we can see a bunch of offset directories. And here is orders 1. So if we take a look at the partition we've described earlier, we can see that partition 1 is on replica 1. So we can see we have orders dash and the number of the partition, and we can see here is where the log is stored. So this is where our message is. Now since we're running 3 partitions, our message could be on either one of the brokers, and we don't have replication, which means our one message is sitting on one of the instances and not on all 3. And we can confirm our message is not on the first replica, because if I do ls -lh on that partition folder, I can see here's the log where the messages are stored, and it is 0 bytes. So let's go look at the other Kafka instances. So I'm going to exit out of this one, and I'm going to take a look at Kafka -2 by going into that one. Once we're in Kafka 2, we can do ls -l and look at the Kafka logs directory. We can see orders -2. So on replica 2, we have partition 2. That's why we have orders -2 over here. And if we run ls -lh on that directory, we can see that we have our log file here with 80 bytes. So our message is inside of this container. We can then quickly head over to Kafka 3 to make sure our message is not in that one. And since we know replica 3 has partition 0, we can say ls -h, we can look at orders partition 0, and we can see the log file is also empty on this one, so 0 bytes. So we know now that our message is sitting on instance 2 in partition 2. And we can further confirm this by going back into that instance, and we can use the cat command to run cat on that file, on that log file in that partition folder, and we can see that our message is printed out. So order 1, which is in instance 2 on partition 2. So now we know the basics of how to run 3 Kafka instances, link it to Zookeeper. We have the basics of how to create a topic, how to split the topic into multiple partitions, as well as produce messages and consume messages. So hopefully this video helped you understand what Kafka is, the concepts, but more importantly, how to get it running and provide you with a sandbox to explore Kafka further. In the next video, we'll be taking a look at how we can use Docker Compose to start up these Kafka instances automatically, improving our development sandbox. And then we'll proceed to take a look at how to build real-world applications on top of Kafka. If you liked the video, be sure to like and subscribe and hit the bell. And if you want to support the channel even further, be sure to hit the join button below and become a member. And also check the link down below to the community page. And as always, thanks for watching, and until next time, peace.